new video. The video is on Ohm's Law. Okay, so Ohm's Law is this law in maths that says that the voltage and current and the resistance, they are related somehow, and what gives the relationship? It's called Ohm's Law. Okay, so Ohm's Law, the way that you'd remember it, I'm doing this for combined science students, not necessarily physics students. Students studying physics, they have to be knowledgeable on how this law comes about, and also the details, they're a little bit more complicated than what I'll be discussing here. But then here, this is just a preparation for combined science students. Okay, we did cover a video on equivalent resistance for series and for parallel circuits. So and for series parallel circuits as well. And then somebody suggested that, okay, you should also cover the calculation for resistance, voltage, and current. Okay, so this is what we're going to do. So whenever you think of Ohm's law in combined science, just know that it's a law that gives the relationship between here, the voltage. Okay, let me actually change my pen here. The voltage, this one is the resistance, and this one is the current. Okay, so the voltage, the resistance, and the current, they are given by this relation here. And this triangle, we always use it to, not always, but then we use it to illustrate formulas sometimes, where we have three entries that are related in some way. Okay, so the current, you're asked to find the current, for example. So the current would be I. So you'd cover this I here and then see how these two are related. It's V over R. So you'd actually know that I is equal to V over R like this. Okay, so what details are you given? So you're given this ohm, that's the unit for resistance. Okay, so R is equal to 12 ohm. This is the omega symbol. So it's a Greek letter. That's what we use for ohm, for omega. So V is equal to 24 volts here, just like what we're given. So now you just have to substitute. Our V is equal to 24 volts, and our resistance is equal to 12 ohms, like this. So 24 divided by 12, you'd obviously get 2 watt amps. Okay, so let me add another layer to this. So these ones, they're measured in ohm. So we call this ohm. Okay, and this one, they are measured in amps. Okay, and this one, they are measured in volts. Okay, that's it. So ohms, volts, and amps, then you're good to go. So we already calculated here, this one would be 2 amps. So you're asked to find the current. Okay, so whenever you're given a question, just do your stock check and say, what do you have? So for example, here you're given that the resistance of a circuit draws current 0.06 amps. So already you know that your current, yeah, this is how you distinguish your I, okay, by writing these bars there. So your current is equal to 0.06 amps, like this. Okay, and then you're given the voltage. Voltage is equal to 12 volts, like this. And then you're asked to find the resistance. So resistance is equal to, you go back again to your formula, resistance is equal to voltage over current. Voltage over current, like this. So you get 12 volts over 0.06, okay, amps. So if you're from primary school, what we do is we cannot simplify this if the denominator is some decimals. So what you do is you multiply by the number of decimal places here is 2. So you have to multiply by 100. It informs us the number of zeros that we should put after the 1. If it were 3 decimal places, then we'd have to multiply by 1000. But then to maintain the balance, we have to do it both at the top or at the bottom. Because 100 over 100, it's simply 1. Okay, we're not changing anything. So here you'd actually get 1200 volts over 6 amps. Okay, so thereby you can just say 6 into 12, then you get 2. So you get 200 ohms. Okay, if you want, you can say 200 ohms, like this. It'd still be okay. So this is essentially how you'd go about doing this. So it's not very tough. So it's a bit of stock check. You just do your stock check. What do you have? What do you need? You go back to your formula there in the triangle, and then you just calculate. Okay. So you can be asked to calculate the power as well. So I'm a bit hesitant to to show you how it's done, but essentially power can be in 3 formulas depending on what you have. Okay, so current times times voltage. So voltage by current times this is power. Okay, so okay, I'm hesitant about doing this, but let me just show you. Okay, so V squared over R, or power is also equal to I squared R, like this. If you can remember these formulas, and that's good if you can remember, but you don't need to remember these formulas. You just have to remember one formula, this, and then you have to use this. Okay, so for example, if I need, we just have to see, so I have voltage and current here, but then I know that power is equal to, I have resistance and voltage here, but then I know that current is equal to voltage times, power is equal to voltage times current. I don't have the current, so I can actually calculate the current separately. Or what you can do is you can substitute out the current. Okay, so V multiplied by what? So current is equal to V over R. Okay, so you get V over R like this. So that's how we get V squared over R in this way, this formula here. Okay, so it actually now say voltage, which is 12 ohms. Okay, voltage usage, which is 24 volts, over R, which is 12 ohms. So this one will be squared, and then you'd get your voltage, your power. You get 48 watts. Okay, so what we did is we had to recall only one formula here. If you're good at math, then you don't really need to recall every formula. You just have to recall one formula, and then you use this one. So you'd have to remember P is equal to, which is power, is equal to voltage times current. Then you'd have to substitute out here. Okay, so it's also the same thing here. So you'd be having, let's say, power equal to VI, but then you don't have, you just have, you actually have these ones right now. So it's this one is pretty easy. So it's simply voltage, which is 12 volts, multiplied by 0.06, okay, amps. So 12 multiplied by 0.06, so they have 0.72 watts, like this. So the unit for power is called the watt. Okay, so watts, like this. So this is it. So you have to remember the formula for power. So it's VI, and then you have to remember this, especially if you're good with change of subject or formula. If you're not good, then you have to remember all these, such that when you're given the voltage and the resistance, you would know that I'm supposed to use this. And when you're given the current and the resistance, you're supposed to use this. And when you're given the current and the voltage, you're supposed to use this. Okay. So let me rub this part, and then we move over to the next questions. Next set of questions. So you should know how to calculate using Ohm's law. You can calculate either the current or the voltage or the resistance, and you should also know how to calculate the power as well, the formula for power. So let's move over to the next question. Next question says, okay, so let me rub this part here. Yeah, so find the applied voltage for a circuit that draws 0.2 amps through this much resistance. Okay, 4800 ohm resistor. So you have current is equal to 0.2 amps, and resistance is equal to 4800 ohms. So now you go back and say, okay, what's the voltage? The voltage should be current times resistance. So V is equal to I R. So now you just substitute. What's your I? It's 0.2 amps. What's your R? It's 4.8 ohms, like this. So you'd actually get so 4.8 8 divided by 5, it's the same thing, so 960 volts, like this. And if you're asked to calculate the power now, you'd have to say power is equal to, you start with your basic formula that I told you, VI, like this. Okay, but then you don't have V. If you want, you can use this V that you just calculated. But yeah, let's actually use that. So it's 960 volts multiplied by the current, which is 0.2. Okay, so 960 multiplied by 0.2, so you'd get 192 watts. Okay, so here I was supposed to put the unit would be amps, like this. So this is one way to go about it. Or you could have said, if you didn't do the step now to actually find the voltage, you could have said VI, and then you'd realize I don't have the voltage, so voltage is equal to IR. So in place of V, you'd put IR here, so multiply by I. So you'd get I squared R. So you'd get I, it's equal to what? It's equal to 0.2 squared times R is equal to 4,800. So 0.2 by 0.2 by 4,800, like this. So you'd get 192 again. So it's still the same thing, okay? But then here you didn't have to find the voltage first. And then that's it. Okay, so let's move over to the next question. Next question says, what is the increase of current when 15 volts is applied to 10,000 ohm to a 10,000 ohm rheostat, which is adjusted to 1,000 ohm value? Okay, so initially you'd have to calculate the what would be the current initially. So we want current, that's what we don't have. And what do we have? We have voltage equal to 15 volts. So whenever we're given the way we have to compare, sometimes it's good for you to say V1, as in you're distinguishing it from whatever you'd be writing later on. But then for this one, the voltage was the same. Okay, they didn't change the voltage, so you'd have to put this one, it's still okay. Then R1 is equal to 10,000 ohms. Okay, so now you need the current. So current is equal to voltage over resistance. Okay, so current is equal to voltage over resistance, like this. So V is equal to 15. Now R1 is equal to 10,000. Okay, so you can put ohms here if you want, you can put volts here. So you'd get what? You'd get, okay, 1, 2, 3, 4. So it gets 0 0.12 and 15 here. Okay, as in this one should be having 4 decimal places, so it should be like this. So amps. This one is your current one. Okay. In the second case, R2 is equal to what? Is equal to 1000. So you'd have a case where you say you have I2 equal to V over R2, like this. And then you'd have to put your voltage, which is 15 here, divided by 1000 this time. So 15 volts, 1000 ohms, and then here you get 0.015 amps. So the increase would be what? You'd be subtracting. So the increase, so which means the change in I would be equal to, you'd be saying 0.015 amps minus 0.0015 amps, like this. So you'd get what? So you have 0.0150 and you have 0.0015, like this. So you need to subtract them. So you get 5 here, then you get 2, here you get 3, here you get simply 1, 0, 0, like this. So it's 0.0135 amps. That's the increase in current. Okay, these ones you're likely never to be asked and are in ZIMSEC, so they will always expect you to apply Ohm's law, this triangle that we have here, and then also to calculate the power. So for our case, we have voltage and resistance this time. So we say that we recall P is equal to VI if you're really good. And then for you to calculate now the power, you now have to substitute out the current, since you don't have. So it would be P is equal to, you'd get P is equal to V squared over R here. So you'd actually get 15 V squared divided by R, which is in this case 10,000. Okay, then you get your answer here. So yeah, that's it. Let's quickly move to the next part. I hope we get a different question here. So here, if a small appliance draws this and a voltage of this, the power rating would simply be the power multiplied by the current multiplied by the voltage. Okay, so the power rating would be VI or IV, just like what they said here. So it'd be 120 volts multiplied by the 10 amps. And also take note that the units, they are standard units. Okay, there's no milli, there's no mega there. It's simply standard units. So you'd actually get 1200 watts like this. Okay, let's quickly move to this. So if a blender is plugged into this outlet, it supplies this much of current, what amount of power is used? So again, P is equal to VI. So you just multiply this. So this was pretty easy. I won't get to it. I think we'll be just repeating stuff. So if a clock expends 2 watts of power, this one is interesting, from a 1.5 volt battery, what amount of current is supplying the clock? Okay, so you have power equal to 2 watts. You have voltage equal to 1.5 volts, and you want the current. Okay, so you're told essentially here you have P, V, and I, and you just have to use the value, the expression for power that connects these 3 elements. Okay, so the power, voltage, and current. So it's this one here. And you ask what amount of current. So here you can divide both sides by V by V. So you actually get current is equal to power over voltage. So our power is what? 2 watts over the voltage. The voltage is what? 1.5 volts here. So you get 1.33 like this. So 1.33 amps. And then that's it. Okay. So this one was interesting, yet you know a little bit of change of subject, which is good. Interesting is good. So our Tommy runs his juicer in the morning. The juicer uses 90 watts of power, and you have this much current. How many volts are necessary to run the juicer? Okay, now you have power equal to 90 watts, and you have current equal to 4.5 amps, but then you need the voltage. Okay, so voltage is equal to something that you don't know. The formula that connects all this is V is equal to P is equal to VI. So the voltage would be equal to, you divide both sides by the current, so P over I like this. So it actually get 90 watts divided by 4.5 here amps. So it get 900 divided by 45. So this one would be volts. Okay, so you get 20 volts, and that's it. Okay, so this one wasn't tough. Yeah, so that's it. This is where just substitution, simple substitution, and just recording this formula and this formulas, this formulae, and then you're done. Okay, so this wasn't very difficult. It was probably one of the simplest stuff that we had to do here. So yeah, but then I appreciate you so much for watching. Make sure you like, share, and subscribe. Yuba out.